Hello everybody, Belmont here. Let's talk about colonizing Mars. Well, the main things that we need in order to colonize Mars are oxygen, water, shelter, food, and energy. And we have to be able to get it from the planet ourselves. We cannot keep relying on Earth to bring supplies back to Mars, back and forth, back and forth. So here are some solutions to possibly fix all of these problems. Now, keeping in mind, the Martian temperature range is from negative 200 degrees Fahrenheit to 86 degrees Fahrenheit. That gives it an atmospheric average of negative 81 degrees. Compare that to Earth, it's much, much colder. Earth's atmospheric average is at 57 with negative 126 degrees to 136 degrees. Its gravitational pull is also approximately 1/3 of that of Earth, meaning essentially if you weigh 100 pounds on Earth, you would weigh about 38 pounds on Mars, making pools of liquid water on the planet impossible. Not to mention, the Martian rotation around the sun is a little bit different than Earth. One, it takes twice as long. Two, it's wild temperature swings on it. And there's a good chunk of it that barely gets to past the habitable zone. So because of that, wind and solar energies that's impossible to do that on Mars. Now let's talk about the Martian atmosphere. Martian atmosphere consists of 96% carbon dioxide, 1.93% argon, 1.89% nitrogen, and 0.18% oxygen and water. So it's not breathable. Because on Earth, it's 78% nitrogen, 21% oxygen, 1% argon, water vapor, and carbon dioxide. So how are we going to substantiate it? How are we going to be substantial on Mars? Well, let's talk about shelter first, because that's an easy one. One, living outside or on the surface of Mars is not going to happen. Why would you do that when you can live underground? See, Mars has some pretty large lava tubes, larger than the ones on Earth. Now what a lava tube is, they're cave-like conduits that are formed underground by cool, hardened lava after molten rock has flowed through. The ones on Mars, again, they're significantly larger than the ones on Earth. And these lava tubes are actually dozens of miles beneath the surface. So it would shelter us from the temperature, solar radiation, and the horrific dust storms that Mars can kick up. So we have our shelter. Now let's talk about food. Well, believe it or not, the Martian soil can actually grow food. It is possible. As a matter of fact, they've simulated Martian soil here on Earth, and it found out that it grows tomato, rye, carrot, garden cress, and several other plants fairly nice. Matter of fact, some of them may even grow better than they would on Earth. So food's not a problem. Shelter's done. Now let's talk about oxygen. One of the things we need to make this all work. Well, technically we need all of these things to make it work. But let's talk about oxygen. Well, the carbon dioxide abundance in the atmosphere of Mars, well, that's again relatively easy. Use a little couple things called electrons, aka use electricity to split the molecules of carbon dioxide into oxygen and carbon monoxide molecules. Now, many people might be thinking, well, carbon monoxide has an atom of oxygen in it, why not extract that other atom to create oxygen and then raw carbon? Keep in mind, carbon is the great stabilizing atom. It makes things safer for transportation. So unless you want pretty much a bomb to go off, it's best to leave it as carbon monoxide. That way, the carbon monoxide can be vented back into the atmosphere, which would then turn into carbon dioxide and produce the whole process all over again, and we would still have substantial amount of oxygen from it. It can be tested for purity and then stored in sidewall oxygen tanks. So that's not really that much of a problem. Now, let's talk about water. This is the biggest issue that we're going to have. There are 3 ways that we can get water from Mars. Keeping in mind, Mars does in fact have polar ice caps. The liquid water would not be held in by the gravitational pull of Mars. The ice stays. And so we can extract water from those ice chunks, but that's a limited supply, so we may have to come up with some other things. Well, glaciers are hidden underneath the surface of Mars. We can extract water from that. Yes, but those glaciers only stretch for dozens of miles. Compare that to the Pacific Ocean. Yeah, that's also a limited supply. Well, there's ice inside the ground of Mars. We can heat up the soil, extract the water, condense it into ice. Well, extracting the water would consist of microwaving the soil. There's also another way. You can extract water from the air. As previously stated, the Martian atmosphere is approximately 0.18% oxygen and water. So in order to get the water from the Martian atmosphere, we would need a little mineral called zeolite. What zeolite does is zeolite can extract the moisture from the air itself. Once saturated, these zeolite beds, they can be microwaved, which would vaporize the water. The water can then be condensed, frozen, and stored as ice. So there you go. That's how. Now, when you combine all 3 of these things, it gives us a lot longer shelf life. But unfortunately, again, it is still limited supply. Now, this limited supply could be very easily canceled out. We would just need more materials shipped from Earth here. Not for a whole length of time. Just for random basic things. Because we will always have to rely until Mars can be fully sustainable. So we need to create fuel for rocket ships in order to transport our scientists and everybody that we need, as well as all the regular supplies. Well, the gravitational pull again on Mars is relatively weak, so we would need less fuel here, or less fuel on Mars than we would need over there. But it still requires fuel production on Mars in order to get to Earth. This is actually an efficient process called a Sabatier process, which combines carbon dioxide with hydrogen at a high temperature in the presence of a nickel catalyst. That releases methane and water. Water molecules can then be reduced to hydrogen and oxygen. And once you have those 3 things, the hydrogen, the oxygen, and the methane, you have rocket fuel. So there's the fuel for that. And now for the big one. We need one thing to have all of this work. Electricity. Many people think, well, solar panels and, you were mentioning Mars having horrible dust winds. Maybe we could use power of wind and solar. None of those are actually feasible. One, the distance between Mars and the Sun is much further than here on Earth. So that's only one problem. The other problem is these dust storms would make the north winds of Dubai look like a gentle breeze. And so that would destroy the solar panels as well as the wind turbines. Not going to happen. That would just be a huge waste of money, waste of supplies, and a disaster that could potentially be catastrophic to colonize Mars. So you would think, well then why don't we just ship a bunch of batteries over there? Well, we could ship a nuclear battery, which is a radioisotope thermoelectric generator. It converts heat into electricity. But Mars doesn't have a whole lot of heat going on, seeing how its average temperature is negative 81 degrees Fahrenheit. So it's possible, but it's not really plausible. That leads us to nuclear energy. This has actually been done by NASA before. NASA has developed a power-producing system that can be used on many planets as well as asteroids. It's a fission reaction in the nuclear reactor that would produce the electricity. Surround that thing by a radiation shield, connect that reactor to the base through a cable, which would deliver power any day or night under any atmospheric conditions in order to shield a nuclear reactor from exploding due to the temperature change in Mars and due to the wind. Simple. You could plant that thing in the ground. So it seems to me that colonizing Mars on the surface is not going to happen anytime soon. But underground, it can all be done relatively soon. As a matter of fact, in as little as 17 years from this date, it is quite possible that we would have colonies on the moon. Or I should say, on Mars. Or quite possibly both. Many people think that by the time 2030 rolls around that this can be done. Well, I really have trouble trying to close out these things, don't I? Yeah, I do. Well, that was your little dose of scientific knowledge on how to colonize Mars. Again, all of these are just working theories. It's all a hypothesis. Because for all we know, there could already be things under the surface of Mars. If we can figure out a way to substantiate life down there, it is a possibility that maybe that's what Martians did. Maybe that's what they do. We don't know exactly what's waiting for us if we try to go into the Martian surface. I mean, the only way we found out those hidden glaciers is through ground-penetrating radar. It was from NASA's Mars Reconnaissance Orbiter, so we're not really certain what's down there. For all we know, those massive hidden glaciers could be the ice supplies for the Martians. But hey, that's just a theory. I'll see you guys next time. Thank you very much. See you later.